Okay, in the last video we looked at how this definition of oxidation and reduction in terms of losing electrons. Oil rig, oxidation is loss, reduction is gain. Right, now we had come across that at GCSE. Now what we're going to do in this video is talk about oxidation number, which is a new concept. And it hasn't got a formal definition, but you can think of it as how many electrons is an atom missing. And you talk about the oxidation number of an atom in a compound, or not in a compound. You talk about its oxidation number, how many electrons is it missing. Now sometimes that's pretty obvious, because if you think about sodium chloride, well, sodium is the Na plus ion, and chloride is a Cl minus, an ionic compound. So quite clearly the oxidation number of sodium is missing one electron, is +1, okay? And the oxidation of chlorine there, well, it's not missing any electrons, it's actually got one it shouldn't have, so its oxidation number is -1. And then so you have magnesium oxide. Let's think of another one, it's pretty obvious there. So magnesium is the 2+ ion, oxygen is the oxide ion, so magnesium is missing 2 electrons, so +2 oxidation number. Oxide got 2 it shouldn't have, so -2 oxidation number. So far you may think, what's the point of this? It just looks like charge. But now let's just expand that to covalent compounds. And this is where it is a bit of an iffy concept, but let's have a look at covalent compounds. So let's think about water. So there's water. And there's a pair of electrons in each bond, of course, right? But are those electrons shared equally? Well, we know that it's not, because oxygen is a very electronegative, isn't it? So it's getting more than its fair share of the electrons in that bond. So you'd say the hydrogen is kind of missing an electron. No, it's not missing a whole electron, but we do say its oxidation number is +1 there. And that hydrogen is going to be +1. And we say, well, the oxygen is getting 2 electrons that it shouldn't really have. So we say the oxidation number of oxygen is -2. Okay, so that would be that's going to be oxygen's oxidation number there. So now there are a few rules about assigning oxidation numbers, and we'll write those down. Okay, so what we're going to say is that because oxygen is, apart from fluorine, it's the most electronegative element in the periodic table. So oxygen in all of its compounds always has an oxidation number of -2. Okay, because it always, like in water there, you can see it's forming 2 bonds. It's getting more than its fair share both of those bonds, so it's going to be -2. Now hydrogen, that is another very important one. That is always +1 in its compounds. Okay, just write in compounds there. In compounds, okay. Another important rule is that uncombined elements such as O2, N2 and so on, but it's always going to be 0, okay? So we're going to look at those rules, and then we also need to understand that if you add up the oxidation numbers in a compound, well, in water, so that's the sum of the oxidation numbers in a compound is equal to 0. So if you think about that example with water there, look, -2 for the oxygen, and then +1 for one hydrogen, +1 for the other, it adds up to 0. But we're just going to refine that ever so slightly, because not everything has got no charge. So For example, you might think of sulfate ion, okay? SO4 2 minus. Well, that's got a charge of 2 minus. It's not neutral. So we're just going to refine that little rule there. And we're going to change that, get rid of 0, and right, get rid of 0. And we're going to say the sum of the oxidation numbers is equal to the charge on the species, okay? Now this word species in chemistry is a bit of a catch-all. It's when you don't want to say molecule or ion or something, you just say, it's like a fancy word for a thing, the charge on the species, okay? So these are our basic rules, and we'll use them to assign some oxidation numbers of different elements now. So let's have a think about sulfur, because, okay, I've rubbed that out. Sulfur, there's lots of different sulfur compounds, and it very often has different, it can have variable oxidation number. So if you think of some sulfur compounds, I'll write down sulfur, and I'm sorry I write pH. It's just that I'm too old to change my ways, really. I know that you should write it with an F now, but it just doesn't come naturally. So let's think about sulfur. So we've got H2SO4, yeah, sulfuric acid. Let's think some other sulfur compounds. SO2, you know, causes acid rain. Let's think of hydrogen sulfide. That smells of rotten eggs. We remember that. Sodium thiosulfate, yeah, you've probably come across that, even if you can't remember the formula. And then let's say sulfur trioxide. I think that's enough to be going. Let's say the sulfate ion, okay? So like let's say we've got sodium sulfate. Okay, let's work out the oxidation numbers of those things then, right? First of all, I'm going to change these two here, because we're not really interested in the sodium. We know that sodium's 1+, so that means the thiosulfate ion is S2O3 2-. We know that, don't we? So, and we're interested in the oxidation of sulfur here, not sodium. So we know the SO4 there in that compound must be SO4 2-. It's always good with ionic compounds. Get rid of the ion and just look at the individual ions rather than the whole compound. Right. So, let's have sulfur the element. Okay. So let's have sulfur the element S. So we know oxidation number of that one is going to be 0, isn't it? That's got to be 0 because uncombined elements. Right, let's do it for sulfuric. Let's do it for SO2. So get rid of that. How annoying is that? Right. So SO2. This charge, the sum of the oxidation numbers is equal to the charge on the species. Well, what's the charge on SO2? It's 0. Sulfur, that's our unknown, S. Do like a little algebra equation. Each oxygen is -2, and we've got 2 of them, so that's going to be S minus 4 is equal to 0. So just do a bit of algebra there. S is equal to +4. Oxidation number of sulfur in that one is +4. Okay, let's do another one now. Let's do H2S this time. So we know, H2S, charge on the species is equal to 0. Sulfur, we don't know. What we say, hydrogen, always +1, isn't it? On the left-hand side there. So we've got 2 of them, so we've got +2. So sulfur there has got an oxidation number of -2. So -2 there. Let's do sulfuric acid now. Okay, so sulfuric acid. So we have got charge on the species is equal to 0. We've got 2 hydrogens, each one of them is +1, so that's +2. We've got sulfur, which we don't know, call that S, and we've got 4 oxygens, each one of -2, so that's -8. So S minus 6 is equal to 0. So the oxidation number of sulfur is plus 6. Plus 6 for sulfur. Let's do it for the sulfate ion, SO42 minus. You can probably see what's going to happen there. It's going to be plus 6, but let's just do it. Right, what's the charge on the species? This time we do have a charge, so that's minus 2. Sulfur, we don't know. S, 4 oxygens, each one minus 2, so that's minus 8. So S is equal to plus 6. So we did that one. Right, SO3, that's an easy one, isn't it? You probably do that one in your head. After a bit, just do these in your head, but start off doing them this way. Right, the charge on the species is SO3, 0. Sulfur, we don't know. 3 oxygens, so that's minus 6. So S is equal to plus 6. Plus 6 is the oxidation number of sulfur there. Right, thiosulfate, left the hardest one till last. So let's do that one. So this is thiosulfate here, S2O32 minus. Charge on the species is minus 2. We've got 2 sulfurs, so I have to write down 2S there. And we've got 3 oxygens, each one's minus, so that's minus 6. So that means 2S is equal to plus 4. Divide 3 by 2, so S is equal to plus 2. So the sulfur has got an oxidation number of plus 2 in thiosulfate. Okay, so you see we've got a variety of oxidation numbers there that sulfur can have. And just if you notice there, sometimes it's useful to put them on a little ladder, so I'll do that. Now the biggest oxidation number we've got is plus 6, and the smallest one we've got is minus 2. So we've got 6, 5, 4, 3, 2, 1, 0, minus 1, minus 2. So plus 6, okay, 0 and minus 2. Let's put our compounds on there. So we've got SO4, 2 minus, and H2SO4, and we've also got SO3. Squeeze that in. Plus 4, well, we've got sulfur dioxide. Plus 2, we've got thiosulfate ion. 0, we've got the element sulfur, and at minus 2, we've got H2S. Now, you can see there that the range from minus 2 up to plus 6, well, that's equal to 8, isn't it? And that's no coincidence, because you've got, well, think of the 8 electrons in the outer shell, if you think of it in terms of the dot cross diagram, right? There's 8 electrons here with the plus 6. The sulfur is using all of its own electrons to make covalent bonds, mostly to oxygen, and oxygen is getting more than its fair share of those electrons. So sulfur is kind of missing all of those 6 electrons. So that's why it's plus 6 oxidation state. Sulfur, let's think about this bottom one here. Well, sulfur here is it's getting a full 8 in its outer shell by forming covalent bonds with hydrogen, and it's getting more than its fair. The sulfur's getting more than its fair share of those hydrogen electrons, so that's why it's minus 2 there. So the full range is 8. There's 8 electrons. We'll see that. We'll do that. We'll do the same thing with nitrogen in a minute. We'll get the same thing. Okay, so let's do it with nitrogen before we finish this video, because nitrogen has forms a lot of different oxidation. Has compounds a lot of different oxidation numbers. Right, nitrogen then. Okay, so let's think of all the nitrogen compounds we know. We have got nitrogen gas. We've got NO2, which is a brown gas that comes out of car exhaust. You can't see it because it's dilute, but it is brown if it's pure. NO also comes out of car exhaust. N2O is nitrous oxide that the gas and air give to people in hospital to relieve pain. Then we've got nitric acid, HNO3. We've got sodium nitrate, NaNO3, and of course what I'm going to do is get rid of that and just call it the nitrate ion, NO3 minus. And then there's a few other more obscure, well, let's think ammonia, that's not an obscure compound, NH3, yeah. Let's put a slightly obscure one, hydrazine, N2H4. Okay, let's do the oxidation number of those. Okay, so sigma oxidation numbers is equal to the charge on the species. Okay. Right, I'm not going to work them all out individually. I'm just going to do the hard ones. Okay, so let's think there, oxidation number of nitrogen is 0. Here, well, you've got two oxygens, it's going to be +4 because each oxygen is -2. Here, it's going to be +2. Let's do N2O, that's a bit of a tricky one. Right, so the charge is equal to 0. We've got 2 nitrogens and we've got an oxygen, which is always -2. So 2N is equal to +2. So N is equal to +1. Oxidation number there. Right, let's do nitric acid properly. We won't do nitric acid, let's do nitrate properly, NO3. So NO3 minus, charge on the species -1. Nitrogen we don't know. Oxygen is always -2 in the 3 of them, so -6. So N is equal to +5. Okay, for that one there. You can probably see that for nitric acid it's going to be the same, that's +5. NH3, well, hydrogen is always +1, so there it's going to be, so we've got N, three hydrogens, so that's +3, each one is +1 is equal to 0. Nitrogen is -3, okay. Hydrazine, let's do that one. We've got 2 nitrogens and +4 for the hydrogens. The charge is 0, so 2N is equal to -4, N is equal to -2. Right, so you can see there, you could put them on a ladder like I did with the sulfur, but once again you can see that it's interesting. What's the range? Well, the lowest one we have is ammonia, isn't it? Which is at -3. And the highest one we've got is nitric acid in the nitrate ion, which is +5. And so once again, you can see there you've got a range of 8 electrons, haven't you? 8 electrons difference, okay? And you always get that when you do these. Okay, so that is basics of signing oxidation numbers, and we'll leave it there. There are a few exceptions to these rules we've got in the blue box here, and we'll talk about them in the next video.